Welcome. In this video we're going to learn about erosion. Now it turns out there are two types of erosion. There's erosion by water and erosion by glaciers. Those are the two major types. And I want to focus on water. And we'll be observing some really interesting things and beautiful landscapes and how they're formed by erosional processes that occur from water. We will observe how erosion creates ridges and valleys and how they're often so very beautiful in their shapes and forms. We'll see how rain can quickly form beautiful badlands and create interesting features such as hoodoos. They're kind of cool. We will see that relatively small creeks can erode spectacular canyons. So these are a few of the things that we're going to be observing. We'll observe more here in this video. And I'm excited about this, so let's get going, shall we? Many of you may question, why would you start early on with something about erosion? And hopefully, if you'll watch through this video, you'll learn to think of erosion in a different way, how the earth is eroded, and some of the beautiful landscapes. In fact, most of the landscapes we see are a function of erosion and the geology that is being eroded. And this is kind of fun for me. It's probably maybe the only video that I'll start right here by my house to show you at a small scale how erosion has affected just a driveway that I built up to the house here. So let's go over there and have a look. The beautiful badlands in the background that I enjoy so much. And we'll be visiting those as we talk about erosion. So right here, where the road comes down from my house, above our house, was this hillside that was built and formed this ramp, I guess would be the word, for the road. And you'll notice these lines that sweep in. One can see already some of the interesting erosional features that have occurred in just a couple years, okay? And I want to make a couple points here about these. Each branch that erodes down here goes down and it starts to merge and merge down the hillside. And it's amazing how much of this erosion has occurred in just 2 years along this little hillside. And it shows these beautiful patterns. Now, if we look down the line here, we see these ridges that I mentioned. And it turns out small things like that can affect erosion a lot and can have an impact in theory for a very long time from initial conditions, a tidy little perturbation, especially if you have units that are pretty homogeneous or uniform. So I want to show you an example of that as we walk along here. As we come up here to this ridge, first of all, these drainages here are kind of ignoring it. They're kind of cutting right through it. But come look right here. Now we have something interesting, and it occurs further on. I don't need to point them all. But see all these drainages, these little mini creeks, right? Mini creeks coming down, and they hit the ridge. And now they go along the ridge, and then they turn down. So this ridge formed a barrier. This subtle ridge formed a barrier, and everything went on down the hill. Now, let's go forward in time. Let's imagine that this was the top of a huge mound of earth, a big uplift that covered half a state or a county, you know, a huge area. And we had a little perturbation that started right here millions of years ago. Can you see in your mind how this could affect the erosion much, much later, even though it eroded maybe 1,000 feet down or something. Let me show you a large-scale example of this phenomena along a beautiful mountain, and it's near Grable, Wyoming. Let's keep our eye on this big ridge here and see how it affects drainage and erosion. See these drainage patterns here and how they're deflected, just like on the driveway, and move along the ridge and then finally break through the ridge. Notice that similar processes are occurring in this area. Believe it or not, millions of years ago, this large ridge that we're looking at was as small as the ridges in my driveway. So it's really interesting how sensitive these systems are to initial conditions. And I think you'll have fun as we learn some of the basic concepts of erosion and apply them to bigger picture items, and hopefully you'll get an appreciation for how important erosion is to the beautiful landscapes we witness all over the world. Well, here we are. We're on top of Tapman Mountain, they call it. And I'm going to be hiking over yonder here a couple miles. I'll show you here in a minute, but quite a ride in the Jeep. Pretty good drive with lots of hills and beauty as always. And I'm excited to get going with this hike and see what we see. So just to show you where I'm going to be hiking to, out into those hills out here to that point out there. And I hope to show you some really interesting erosional features at the larger scale when I get out there. Well, one thing that's always enjoyable when you're doing a hike as a geologist, you're just enjoying the outdoors, and you're thinking of the world and how it was created and how these beautiful layers of rocks were deposited and eroded, and the animals and the plants and everything about it. I just think about it as I hike along, and sometimes you come across some fun things. Let me show you here a fault that I came across. It's really cool. So if I show you here these beautiful colored beds, they're almost vertical, whereas everything else all around here is very flat. So this is a beautiful fault that slipped down on the right side and just rotated it, just took the horizontal bed here and rotated it vertical. And then of course there's just the fun of hiking along on these beautiful badlands. They're pretty impressive. As I think about this geology here, I'm thinking about the world 50 million years ago. These river systems that had a lot of mud in them. All this is soft dirt, mud. Every now and then you'll see sand channels. Well, I've been hiking along and thinking about the world in the past 50 million years ago, and I came across this little area and stumbled on something kind of fun. Let me show you. So I saw this little ledge here that you can see in the foreground, and right there, and I thought, you know, this looks organic rich, meaning lots of plants were around and died in the water and were preserved. And I was thinking about the world as I walked along. the geologic world, as we'll say. And lo and behold, I came across a petrified, we'll say a large limb or something. See these light-colored rocks? Those are it's a petrified limb or a small tree scattered all about here, coming out of there. Pieces scattered down the slope. They're quite fragile, but it's just a nice indicator of really what the world was like. Very different climates, subtropical at the time. But onward and we go to talk more about erosion. Okay, so I've made it to the spot I want to be. What a hike, and I've still got a long way to go to get out of here, but that's all right because it's been spectacular. I've seen a lot of wonderful geology. As I show you the bigger picture of erosion and scale it up from where we saw it, even in my own driveway at my house there, I want you to see some of the patterns, some of the smaller patterns and how they develop into larger patterns. And that this whole area here is pretty soft, shaly dirt, most of it, very similar to where my driveway was built. And also keep in mind that this basin, the Bighorn Basin, was full of sediment, clear to nearly the tops of the mountains. So probably 4,000 feet more of sediment on top of me here at one time. And it all eroded down to the present day. And hence, we have these dramatic erosional features in these badlands. And it's a great way to see the power of erosion. So let's start flying along, pretty much along the path that I've hiked to get to the top of Sheep Mountain. And I want you to pay attention to some of the erosional features that you see. Let's drop in elevation and make some observations in this area right here. So right here, we can see similar drainage patterns that we saw in my driveway, which of course are a much larger scale here. As you might imagine or observe, I could draw hundreds of these blue drainage lines in this area. In fact, I could draw probably 100 drainage lines in this small area. And moving to a very different scale, a very large scale, let's move across North America here and observe the drainage patterns. Indeed, they are similar to the very small drainage patterns we observed in my driveway, to the larger drainage patterns we've observed out here in the hills, and to medium size and all sizes, basically. This is known as fractal in nature. So nature often has patterns that are fractal, which means they're similar at all different scales, from the small to the large. Let's continue on to the top of Sheep Mountain here, where I've hiked to and enjoy some beautiful badlands scenery. We'll be looking at other erosional features as well and discussing what they really mean. And hopefully you'll notice these types of features in your area of the world, wherever you might be, and as you drive down the highway. Well, it's another day out here talking about erosion and the power of erosion and the beauty that it creates. A couple days ago, I hiked up to the top of the mountain there to show you some larger scale erosional features and how we see similarities between that and the smaller scale. And this afternoon, I want to show you how erosion combined with the geology creates beautiful things for us to enjoy and helps us think about the world around us as we interact with the outdoors and think about what was in the geology and why are the hills the way they are or the rocks the way they are. And again, as I've said many times, it's this combination of factors, right? So we're going to do that here today, and hopefully you'll appreciate some of the beauty. Okay, I've been hiking around in this Willwood Formation, which I've talked about as primarily pretty soft mud stuff. Boy, the rain gets in here, and sometimes it can be really loose. These were muds deposited in these river systems that had a lot of mud that flooded out over the main channels out into the plains. Now, when it comes to erosion, we've seen kind of what happens when you have just primarily this loose, nice shale that the water is coming down and dripping through. And now here we don't have any real good erosional features, but I want to propose something for you to think about. What would happen if in the middle of this shale I put a layer of sandstone? It's almost like a layer of cement right sticking in the middle of here, a horizontal layer. And I had the soft stuff above and the soft stuff below. What kind of things might we expect as this erodes? What's going to happen? So here I am with my trusty sketchboard, my whiteboard here, to make this, hopefully try to make this really clear as to what happens when you put a layer of resistant rock within soft rock. So this sketch here, this black layer here, we'll say is a nice durable sandstone, okay? And then above it is some soft shale, kind of like we've been looking at, and underneath. And let me put a tree here to make sure we always understand, what I'm talking about as far as the view that we're looking at. So it's a cross-sectional view across through the ground, so to speak, and with the tree here. Okay, now, so I want to use this whiteboard to help us understand what would happen. And I think when I show you, you're going to say, well, that's pretty obvious. And again, that's one of the things I like about geology is when you think about it, it makes sense most of the time. So we have this resistant sandstone. I've also put in a couple fractures, okay? Weak spots, we'll say. Tiny hairline fractures they could be. They could be other things like slightly more mud in the sandstone or other things. So we start eroding this land through time. Let me use my finger. And we start eroding this shale down, 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 down. Keep eroding it down, down. Pretty soon we're left, I should have grabbed my red marker here, but I'll use this green. Pretty soon we're left with just a little bit of shale on top like that, right? It's coming down, but in this area, when it gets down to some point, water starts getting down into this sandstone a little, say here and here. And then you have just natural processes that are chaotic that we really don't necessarily understand all, but it comes and goes. So maybe it starts dipping down and down here, like this. Something like that maybe. And then it keeps going, right? through time, and then maybe now it's starting to eat really big. And in fact, it starts eating into the sandstone right here, along this weakness, and along this weakness, and along this weakness. So now what we're left with is the sandstone has a notch in it here, and maybe a steep little notch here and here, right? Kind of makes sense, doesn't it? And we might be left, I'll go ahead and put a little bit of remnant of shale here and there, just little bits of it, okay? Now what happens? Well, you could guess, couldn't you? Yeah, I think so. You cut deeper and deeper, and this is the weak spot of this sandstone, and it provides a conduit for deep erosion to occur. And it starts hitting here too, and here too. Okay? Like something maybe like that. Let's do that, okay? So let me take my trusty marker here and redraw the surface. You might have a canyon like that you come across. Maybe a steep little slot canyon here and another little canyon. I say canyon. An erosional cut. You know, it's not that big. We're not making it huge. Okay, so if you were to walk along at that point in time, you'd come here and you'd go, whoa, there's a big gap here. The sandstone is gone. Another gap here. This layer has gone, and it's very resistant to erosion. But you have these flat spots here. Then, let's take it the last step, okay? If I take it the last step for this discussion, of course it could keep on going, it just keeps eroding deeper and deeper down into this shale, right? And it erodes here, and this is interesting. Maybe these two little cuts, mini canyons we'll say, they merge, and this piece of sandstone here, this little hoodoo almost sitting there, is gone, and now you get another canyon, or mini canyon we'll say. So now I'm going to draw this. Okay, something like this. Okay, this is highly exaggerated. This tree, of course, still isn't up here. It's moved down right through time. This takes a long time. But interesting, now what we have is a flat piece of sandstone here on the top, quite flat. This is how mesas and stuff can form. Another flat piece here. Maybe this could turn into a cool hoodoo, which we'll be seeing here shortly. And now you can start to picture. And if this sandstone had lots of imperfections in it, we'll call it, whether they're fractures or things that occurred in the depositional process, it can make this very interesting, as we're going to see. So hopefully that helps you understand clearly that this provides a layer that it's hard to erode down through. And sometimes, if there's no imperfections in there, you can have, I'll redraw this real quick, you can have a layer of sandstone, a mesa type thing, and for a long ways, where because the erosion just can't occur, but wherever there's a weakness, so you can get into that shale, it's going to get into there, and it's going to start eating down and making this unstable. Here you get these steep banks and all that you see so often. So I hope that makes it a little more clear. Let's go see some neat effects of this. So here we see this sandstone with the soft sediment under beneath, or not sediment, but rock, soft shale, and above, and the sandstone itself. Now this sandstone is setting up to make a very interesting, some very interesting features as it erodes, as I'll show you here in a minute. And notice how it's kind of lumpy feeling, and there are holes in it. That's because there was a fair amount of mud in the system, and it worked in with the sand, and it was fresh water, and you had these shrimp basically burrowing in these sands just as a sideline. But this sets up for very interesting. And again, this is a combination of geology and erosion. So as this erodes out, these lumpy sands within this body here are going to be important to make a beautiful landscape. So this is the layer of sandstone that we've been talking about. And really cool surface, texture surface. And then these boulders that are weathering out and how they come out, just beautiful to photograph. Beautiful little toadstools. Let's look at what we call a toadstool, which many of you will be familiar with. Look at this little guy. A photographer, and I like to do that as part of my hobbies as well. Just really enjoy this, thinking about getting beautiful compositions with Mother Nature and the sandstones here. How they weather out, this little finger of sandstone here. and how it comes out. The intricacies of this weathering is just so fun. And you combine that with the beautiful geology of the red and purple and orange and white mudstones above and below, and you get a very, very beautiful scene. Let me just walk along here just to give you more feel for this. Very interesting and beautiful, as I've said over and over, but I get so excited about this kind of stuff. And for me, it's geology, it's erosion, it's sandstone, it's shales, it's 50 million years old. And when I think of that 50 million year old sandstone that is weathered out because of erosional processes with water and millions of years, and the full history here, it is truly breathtaking. For me, it's no different than looking up into the night skies and seeing the spectacular stars and all the big space and the impact that it makes. So here I am in a slightly different area, about a half a mile away, kneeling next to some smaller hoodoos here, or toadstools. Bigger ones tend to be called hoodoos. And one might ask, well, I think I've seen photos of larger ones. Aren't they called hoodoos? And indeed, and we do have them here. Let me show you. I'm going to turn the camera around and we'll take a look and see what we see. Stand up here and just turn that camera right around and reveal the beautiful hoodoo here and walk along. And you'll notice in the distance there are more big hoodoos. And they're all about here. But this one is kind of my favorite that I've encountered so far. There may be more that I'll discover later. That's the beauty of hiking around as a geologist. So I'm going to walk up to this hoodoo here, this bigger beauty. And let's enjoy the beautiful coloring of the muds underneath, the banding within those that indicate different levels of soil formation, which I'll talk to in the future when I get into the geology of this particular formation, capped by a big piece of sandstone. And we saw miniature versions of that earlier today. And now we're starting to get a sense of how these form. We can surmise that, well, in fact, this big piece of sandstone was part of a larger unit, and that the rest has weathered away around it, because this shale, these mudstones and shales underneath, are very weak, and they weather and make things around it unstable. And so we combine that geology, we combine the geology with the erosional processes to make something truly magnificent. Well, now that we've made some observations, I thought I'd give you an opportunity to take a test. Sorry about this, but let's see what you think about this clump of dirt here, this beautiful mound of dirt. Why is that there? Why do you think? Given what you know and what we've seen, what we've learned, why is it there? There was a large sandstone sitting on top of that piece of sandstone that protected the ground underneath it from being eroded away, and then the sandstone fell off. So that's how you can reason through things, and you're doing a great job. So there you go. And to make my point a little easier, look what we have right over here. Yes, indeed, beautiful hoodoos. Very interesting hoodoos. And you can imagine if the rock fell off, the big chunk of sandstone, and the rain continued to pour over a long period, you would have a mound like that over there. Indeed. And I think I'll walk over here so you can enjoy a couple more hoodoos and some of these toadstools, sandstones, or mushroom looking things. Boy, they're sure beautiful. Now you know how beautiful landforms like these I photographed were created. Okay, here I am on top of the tallest place in the middle of the Bighorn Basin. In the central part of the Bighorn Basin, there's a mountain we call Tapman Mountain, which is primarily in the Badlands. It's not a mountain with pine trees on it, but we're at 6,000 feet. Whereas in the basin down below me, we're just over 4,000 feet, 4,300, 4,400 feet, depending where you're at, even down to, I think, close to 4,000 feet. So I wanted to come back here because this is where I started this hike that I went on to the top of Sheep Mountain in the Badlands, through the Badlands, and we observed together some beautiful erosional features and how the Badlands were eroded. And I wanted to make a couple points as we look down on Sheep Mountain. So this is well above the elevation of Sheep Mountain that's down below here, where I hiked through these badlands, these ruggedly eroded badlands. But there's something else from a bigger picture that I wanted to communicate to you that's important to me as a geologist. And that is a little bigger perspective here. It turns out that in the distant mountains you can see back here, and they're behind you as well, and I may pan around and show some of that. But this basin was completely brimful of sediment up to the tops of that flat area on the mountain, about 10,000 feet on the Bighorn Mountains to the east. Only the higher peaks were above the sediment fill. This basin was filled, and it was very flat, filled just full of sediment, deposited by ancient muddy river systems that I've talked about, where they deposit all this mud with some occasional sandstone channels and sandstone beds in the system. So when it had filled up, this basin was full of sediment 4,000 feet above where I'm standing right now, over 4,000 feet. Okay, so as I talked, the uplift of the mountains, the Rocky Mountains, what we call the Laramide uplifts, or orogeny, we use the word orogeny for mountain building events, occurred about 65 million years ago. And so I'm going to draw the mountains, the Bighorn Mountains here, I'm going to exaggerate this to make my point. Let me redo this here. The Bighorn Mountains were uplifted, and then there are other mountains to the west, the Absaroka Mountains, and in that region towards Yellowstone. We had the Bighorn Mountains and mountains to the west, and actually all around this basin, the Bighorn Basin. Now, as this uplift occurred, these mountains uplifted, massive amounts of sedimentary and igneous rock were eroded off the tops of these mountains as they were uplifted and filling in the basin. So it was just filling in the basin like so, and filled it right up to very close to the tops of the mountains. Just hard to imagine, isn't it? And then about 10 million years ago, this whole thing was uplifted, the whole broad region, and incisions started to occur, or erosion. So imagine this, I'll use my fingers and use the power of erosion with my fingers, and it took this out, and it took this out, and this, and this, and this, etc. You get the kind of the picture. And I'll redraw now, kind of diagrammatically, cartoon-wise, what we have today. So we have a rugged surface, a top here, maybe some flats here, rivers in here, down in the basin. So we're looking at a cross-section here. I'll put a tree here so to help us think about. We're looking at this view here, what we call a cross-sectional view. And I am standing on, right now, Tapman Mountain, which I put here diagrammatically as a flat-top mountain right out in the middle of this basin. And it creates this beautiful plateau, and it turns out there are quite a few plateaus out throughout this basin. I've talked to you, let me come a little closer here. I've talked to you about things that are really hard to comprehend. We're talking the amount of sediment here. This basin is about 80 miles east-west and 110 miles north-south. You've had this just phenomenal amounts of erosion off the tops of the mountains as they were uplifted, filling in, and then erosion of everything else. And you wonder yourself, how could this possibly be? You know, when I first started studying geology, I certainly felt that way, until I started incorporating what I'll call deep time. Huge amounts of time. It turns out we can date about how fast the erosion is occurring. And you know how much it is? It's 7 inches per 1,000 years. That's less than an inch, just over a ½ inch per 100 years. Now, as I've shown you, and I've used my rock hammer, and we've walked around on these shaly, muddy systems, muds that create shales of these river systems, you see they're easily eroded. And you see it quickly fill in the ponds they make, and you see erosion. You look at old roads out here that were made in the 1930s and 1950s, heavily eroded. So now you start thinking, well, okay, wait a minute. Maybe it's not so hard to remove this amount of sediment. Maybe, because when you involve long amounts of time, all you have to do is erode a little more than a half an inch, say 7/10 of an inch or so, per 100 years. And now it starts to become, I'm starting to understand how these unbelievable geologic processes can occur, and how what we see and how we interpret the world around us geologically, how it can happen. Isn't it fascinating? It sure is to me. Now that we've discussed the regional geology of the area, I want to turn my attention to this flat-top mesa that I'm standing on and reveal at least a bit of the geology of this fascinating mountain. It's pretty hard to see here, but this is the flat-top mesa that I was talking about. It's a long, narrow mesa that goes for several miles from east to west, Tapman Mountain. And as I mentioned, there are several of these flat-top mesas out here. And now, with some of the tools that we've learned about erosion, you might be able to think a little independently of me and think, why do we have such a flat top out in these badlands? Why would we have such a long, narrow, flat top? There's got to be something going on. You know, that's how we as geologists like to think, is when we see something that just doesn't fit in quite right, we immediately try to figure out why that might be. Well, let me give you some more information as to why we might have a mesa out here, a high mesa out in the middle of the badlands in the middle of the Bighorn Basin. Well, look here, what are we seeing? I'll tell you what we're seeing. Oh, big old cobbles, almost boulders. Oh, lots of it, lots of it. Cobbles, pebbles. What's really interesting as a geologist, if I start looking in here, I examine and I go, oh, these are volcanic in origin. These came from volcanoes. Rounded river rocks that came from volcanic rocks. Some beautiful coloring in here and whatnot. This is a bit sidelined here, but it's still kind of fun. So, wow. Turns out that there's about 15 feet of this in here, right on top of this, that's on top of this mesa. And with the principles that we've learned about erosion, I hope you're starting to think, oh, wait a minute, 15 feet of rock like this, cobbles and boulders and pebbles and all this, in badlands, that's soft dirt around. That's kind of like pouring cement out here, isn't it? It's very resistant to erosion, which means everything around, off to the sides where this layer of gravel was deposited, erodes down, 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 and it leaves this here. So look down into the basin, just eroded down, down, down. And we're left with this flat top mesa. It turns out that the rivers of the time that put this in, laid in this, are kind of braided streams, we call it. They kind of wander all around, and they were heavily laden with these boulders and cobbles from the mountains to the east, or to the west, and laid out a wide ribbon of this type of deposits, river rock deposits. And it turns out many of the mesas in the Bighorn Basin have this same geologic situation where they're capped by all this river rock. Now, I brought up volcanoes here just because it's kind of fun. These are volcanic rocks, kind of slippery volcanic rocks, with all these beautiful coloring, some greens in here, and reds and rusties and purples. It turns out volcanoes can form really nice mesas too. I was in New Mexico a couple weeks ago, driving along in my car, and saw a beautiful mesa. I'll show you in video, of a mesa that was formed in kind of a similar way, in that a volcano, big volcano erupted, all this lava poured out, a big thick river of lava, put in a layer of lava, I don't remember, we'll say 15, 20 feet thick. That lava is just like cement. So when it came out, it was in a low area, right? It's liquid, it flowed into the low area, and then everything around the sides of it through time eroded more quickly, and the lava was resistant to erosion, and therefore it created a mesa. So that's another way to form mesas. So almost all mesas are there because for some reason that area is resistant to erosion. And whatever happens to be resistant to erosion is also kind of flat on top. That helps too, of course, to have a mesa. It's kind of fun to learn these things, isn't it? Just with some basic geologic principles, you can start to think about landforms that you see in your part of the world. Let me see if I can get out of here. Why, hello there. This afternoon I'm out near Sheep Mountain Anticline. I'm a few miles from it, but in Wyoming space. It's not too far away. Near Grable, Wyoming. I wanted to come here and point out another principle. We've talked about various erosional features and how erosion shapes the landscape we see. But I want you to look here with me and see this bed of sandstone, fine-grained sandstone, tipped up like this and forming a ridge. If you look down, you can see that ridge, right? And then I come over here, and if I come all the way over here, I can see the next ridge. And it's tipping about kind of the same. It's pretty steep, so you have one there. And they're tipped going up into the sky, or at least they were, and they've been eroded off. These layers of sandstone. Now, if you'll recall, one of the fundamental principles of geology here is that everything started flat, remember? Everything was deposited flat, and now we observe this. This is a whole nother video, or it'll be a series of video on structuring, deformation of rocks and things, but structure. But for this erosional thing, I wanted to point this out because when we have differential erosion that form things like hoodoos and whatnot, and these other landforms, we have it here too. And I want to grab a sketchboard to help us understand why we see these ridges, and you'll see how it opens up a bigger and bigger picture when you combine, again, this is sounding like repeating it a bit too often, when you're combining this erosion with the geology. So let me get my board here, my sketchboard. I have a tree here that I like to do for cross section, so it's like a big trench cut across the earth, deep into the earth. Here's a tree, so we help visualize that it's a cross section. This is not to scale, it's to show you some principles. And in particular, what you're viewing here, and you're going to see in bigger scale here in just a minute with some drone footage to help us see the bigger picture. This is the land, so I could drive my Jeep right along this surface, right where this tree is. And these are the rock layers like we see here. Now, we've talked about when you have hard rock, how it doesn't erode as easily as soft rock, or soft rock erodes more easily is another way to put it, right? So let's do that right here. I'm going to use my finger to be erosion here, and let's say this red big line here right in that area is very resistant to erosion, and the units either side are softer. Well, what happens? Let me do that. Erosion comes in and it starts eroding. Something like this. Okay? Let me put a little valley in here. Okay? Because it erodes more easily. And on this side, I'm going to say this is soft, so it erodes down. So it erodes something like that. my tripod here wasn't working, so unfortunately I'm trying to draw left-handed and all that. I should be on the other side. So you have a resistant ridge here. Let's do that again. Let's say this guy is resistant, hard like cement. So I'm going to pull this down even further. And something like that. It's hard to draw left-handed. And then I'll say this is soft, really soft, okay? So here comes erosion. I'll take that out. And I'll say now the land surface is kind of like that, etc. Often cyclical, or cyclical. Okay, so we have a ridge poking up here, a valley, a ridge, a valley, a ridge, a valley, etc. This is very common when you get in the arid west, where you see this scenario unfold when you get deformed rocks, where you get these ridges. And even back east, you know, bigger scale, you can see these ridges and valleys. So oftentimes, if you're driving along, and you're driving out along your car in a highway or on a highway or road somewhere, and you're in a valley and there's a ridge on each side, it's probably because of this. So again, you get an opportunity to think kind of like a geologist. You might be driving down that valley and there's a ridge on each side of you because it's resistant, it's hard rock. So with that principle, let me show you this again, what we're looking at, right? A ridge. This little layer here is probably, well, it's a little thicker than what you see here. I'm looking down, you know, it's a foot or so thick. This guy. That one's a little thinner, and there'll be other ridges around, okay? And now I want to step down, down here, and show you the bigger picture and help you imagine, wow, how this can unfold, this erosional process can uncover and develop and unfold beautiful terrain.
Aren't these some beautiful ridges and valleys? How many do you think there are? Let's enjoy some more beautiful landscapes formed by ridges and valleys.
Well, we've made it to the last stop here, meaning the last stop in this whole series, or this whole video, I should say, on erosion. You know, the discussion we've had on erosion could go on, and I could go to many, many places, and I've got to cut it somewhere. And I want to show you one other feature of erosion that we're all familiar with, and that is the formation of canyons. I remember the first geology course I had, college level, you know, university level geology course, and they taught us that the rivers and the creeks cut the canyons that they're in, that these creeks go down. And I was frankly shocked that they literally cut it down in. And because I had envisioned in my mind that rivers were there because the canyons were there. In other words, that there was some massive fault or fissure in the earth or something that cut it open or separated the earth. And that's where the rivers and creeks went through. And in this case, I want to show you here what happens when this is a small creek that cuts a beautiful canyon, spectacular canyon, here on the west flank of the Bighorn Mountains. And there are many examples around all through the world of this occurring, including, of course, the Great Grand Canyon. But this is kind of in your face, and it's nice because it's a small creek. Let's go take a look at this, and I think you'll be impressed what you see. What a small creek. I mean, this is a creek that is just barely big enough to have a few fish in it. And see what it has cut over millions of years. Let's go check it out, okay? Well, here I am up on this kind of a beautiful column standing up on the edge of the canyon that you saw in the drone. And I want to thank you for watching this video on the power of erosion and what it does. And I hope that interests you, and come along with me on some more trips learning about geology. Thank you.